Yeah. For those of you that want to know what we're all about, it's like this, yo. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, 100% reason to remember the name. He doesn't need his name up in lights, he just...
Hello, this is Wharton, back and better than ever in Unit 7. This is 7.1, Exponential Growth and Decay. Now, in this particular unit, we're going to be talking about exponents, logarithms, natural logarithms, stuff like that. It's basically another way to write exponents. So back in Unit 6, we did square roots, which were technically exponents, or cubed roots or whatever. And then this one now, we're going to have another way to kind of write exponents. Hopefully these videos won't be too long, so let's kind of bear with me and let's get going. So exponential growth and decay. If the variable is not in the exponent, then it is not an exponential function. Basically what this is your exponential function here. Y equals a times b and then to the x. And you can tell this b is the only thing being raised to that x. So it means if this x is not in the exponent right there, then it is not exponential. And we'll get to what exponential looks like and so on. Now this a value is what we call the initial value. Initial value, there we go. Okay, it's what you start with. So if you're putting money in a bank account, whatever, that's the amount of money you're starting with. This b is what we call the growth factor, or in this case we call it the decay factor as well. So it's either or. We're going to use both of these in this lesson, growth and decay. So that's what that b stands for. We'll get to understand what it means, what it looks like, how it occurs, and stuff like that. Condition 1, there's two things that make this exponential. One is a cannot be 0, because if a was 0, that makes all of this 0, and that means it's not exponential, it's just a line. And then condition 2, the base b is positive. So this number here has to be positive. It cannot be negative. Then that would not be an exponential function. Okay, it can be higher than 1, smaller than 1, so on and so forth, but it cannot be less than 0. So there's kind of the rough kind of sketch, and now let's kind of get into some problems here. Okay, what I want to do is I want to go through these 5 functions here, and I want to see, is it exponential? Yes or no? If it's a yes, then I want to find out what the a and the b are. If it's a no, then I don't have a and b because it's not exponential. Okay, so is this, or are they exponential? Well, is the x in the exponent? Yes. So this is exponential. The number that's there is only our b. So our b is 2, but our number in front of it is technically a 1, right? It's 1 times it, so our a would be 1 in this case. Second one, is this exponential? Is the variable in the exponent? No. So therefore I don't have any of this. Number 3, is that exponential? Yes, it's in the exponent, yes. So our a value is the first number, right? The initial, -3. And our b is the number in the parentheses as 2.6. Fourth one, is this exponential? So yes, it is, because there's x up there, so yes. What is our a value? It's still 10. Now here's where it gets a little tricky. Because this is a negative x, I need this to be positive. This x has to be positive always. So in this 6, remember from 6.4 we talked about negative exponents and what happens to it? A negative exponent just flips the number that's there. So instead of this being a 6, it's now 1 over 6. So that's our b value. Not 6, it's 1 over 6. Please make sure you don't forget that. There's going to be multiple problems where you're going to see a negative there and you got to kind of adjust. And then this last one, we don't even have an x. We have this letter e. This letter e stands for, it's actually a number that's used for continuous compounding interest. So this actually is a number. So there's no variables x here, so this is not exponential. So I'm sorry, this one was yes. Okay, so that's a no. That one is not exponential, therefore they won't have a and b. Okay, let's get into some graphs on what exponential functions look like. Okay, these two graphs here, I want to have, one is going to be linear, one's going to be exponential. So if f of x equals 2x. So this is just a linear graph. Basically, it means that we have our point of origin right there at the origin, right? It's one of our points. And then I go up 2 over 1, up 2 over 1. And again, I have my line that looks like this. So it's a straight line. Linear is a straight line. In this one here, I'm going to say 2 to the x. So 2 to the x. What this looks like is, so 2 to the x looks like this. You can tell it's not a straight line. It basically starts off really, really small. And then all of a sudden it gets to a certain point and then boom, it just shoots right up. Okay, it's basically shooting up at such a rapid arc. That's where we get the exponential function from. It starts off really, really small because these numbers are really, really small. It's never going to be equal to 0. It's going to kind of run along the x-axis here. And then it gets to a certain point, then all of a sudden it gets to the x values being positive, and then it just rapidly shoots up. Okay, this is one example of exponential function. There's multiple examples we'll get to, but you can tell they're very different. And please make sure that when you're writing these, you make sure you put the x in the exponent. Don't just write it as like something that looks like that, because then I'm not sure as to what you're doing. It will be marked wrong if it's supposed to be up in the exponent up there. So make sure you exaggerate the places of the x, or whatever variable we're actually using when we do word problems and stuff like that. Next section, how do you know if this function represents an exponential growth or an exponential decay? Well, it's an exponential growth if b is greater than 1. Okay, if it's 2 or 3 or 4 or 1.01, it's bigger than 1, and therefore it's a growth. That means it looks something like this, or in some general shape of that. It's an exponential decay if b is less than 1 but greater than 0. Remember, it has to be in between those two values. It can't be anything less than 0. Okay, and that's basically what a decay is. So those are the two kind of rules we can tell if it's a decay or a growth. So now what we're going to do is I'm going to skip ahead a little bit and go to the section that we have these problems on, and then I'll come back and do the rest of them. Okay, so I'm going to skip ahead here a little bit. Okay, this is in the middle of the second page, and I want to identify if this is exponential growth or decay. Look at the b value. This number here is bigger than 1, so that means this is a growth. This number is in between 0 and 1, so that's a decay. This is in between 0 and 1 as well, so that's a decay. Okay, so real quick, I want you to pause the video. D, E, and F, I want you to pause the video and see what you get. Okay, letter D, 5/4, that's bigger than 1. It's 1.25, so that's going to be a growth. That wasn't too bad. E and F are the ones that are hard. Well, we talked about negative exponents, so this is really 1/5, which is 0.2, so this is a decay function. Decay, there we go. And then letter F here, this is again a negative, so this I got to flip it, so it's 10/7, which is 1 3/7, you know, so 1.42 something. And this will be in a growth function because it's bigger than the number 1. Okay, so that's how you're going to do these examples on your practice. How do I know if it's a growth? By looking at a graph, or a decay in this case. So, or a decay. Well, a growth function, what happens is it goes along the x-axis at some point, and then all of a sudden it starts to get away from the x-axis. What I mean by this is starting on the left and going to the right, it starts off really small, and then all of a sudden it shoots up, or it starts off really small, and then it shoots down real quick. So that's a growth. It looks like this. Well, this one here, if I'm going left to right, it starts off high and then goes low. So this would be our decay function. This one here, it starts off really low, and then all of a sudden it goes away from that axis. Okay, so this is a growth. These last two, we're not going to really do much with these, but I'm still going to show you how this is a growth, and then this one is here a decay. So go left to right. So this is our line that we're kind of using. And in pre-calculus, you're going to refer to this as what we call an asymptote. I'm not going to get into that right now, but it's called an asymptote. There you go. And that's a point that it basically is what we call limits, stuff like that, but that's not a big deal. So it starts off really low, and then all of a sudden it goes high. So this is why we call that a growth as well. And this one here, our asymptote would be right here. And then it starts off low, and then all of a sudden it goes really close to that. So this would be a decay. Okay, that would be a decay. All right, so that's how we can tell if it's growth or decay, just by looking at the graph. Now let's actually do some graphing. So let's go to the first one here, number 1. Y equals 1/2 times 2 to the x. Well, how am I going to graph this? On your power assignments, you will not be given a graphing calculator, or you cannot use a graphing calculator to graph these. You actually have to do the math. You're just not going to be able to. Now, if you use a graphing calculator, it's not. I don't care if you use it for the calculations, but you're not going to plug it into your calculator and graph the functions. Okay, you cannot do that. You can do it on a practice just to check your answers, but you cannot do that on your power assignment. So here we go. what I'm going to do is I'm going to graph this, and how I'm going to graph it, I'm going to pick 3 points. I'm going to pick -1, 0, and 1. And these are the 3 points I want you to use, and the reason why is these are going to be easy numbers to kind of plug in. You can even do these in your head usually and get answers quick, and then it should be on a graph, some of them. So if I plug in, let's start with 0 first. If I plug in 0, that make anything to the 0 power is 1, so that's just 1/2, so that's just 0.5. So 0.5 is going to be down there. Then I plug in 1. Well, 2 to the first power is just 2. 2 times 1/2 is just a 1. Okay, so that wasn't too bad. So if I plug in 1, I get 1. Now let's plug in -1. Well, if I plug in -1, so it's really 1/2 times 2 to the -1. Anything with a negative power I flip, so this is actually 1/2 times the 1/2 that's already there, so that's 1/4, which is 0.25. So I'm going to kind of get close to that right there. Looks good. Now again, you can kind of see that it's going to start off low, 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 get low, 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 low. And then all of a sudden it's going to shoot right back up. Because I don't need to do this, but if I plugged in 2, 2 to the 2 is 4, right? And then 4 times 1/2 is 2. So that would be 2 as well. This 2 here is basically doubling what I get from the previous number. So technically 1, 2, 3, 4, this should be up here. And then what do you think the next one would be? Yeah, it would be 4, right? You plug in 3, you get 4. This number here is doubling. This column doubles. Now, on your power assignment, if you ever have to take this online for 7-1, your answers for graphing these, you're not actually going to graph them. You're just going to write these ordered pairs in parentheses, right, with a comma, separating them, and then write the next one and so on. Okay, and that's how you're going to write your answer. What are those 3 numbers? Use -1, use 0, and use 1 as your x values, and then find your y values. What I want you guys to do is to do example 2 and example 3 right on the right-hand side. I want you to do them real quick. Pause and hit play. Okay, the first one there, number 2. Again, I want to always use -1, 0, and 1. You can use other numbers if you want after, but these are the 3 that I always want you to use. Always, these 3. Okay, so I plug in 0. Let's always do that first. If I plug in 0, that always makes that go away, basically, so it's just the a value. Basically, if you think about it, if you always plug in 0, you always get the a value, whatever the a value is. In this case, it's 1/2, so or 0.5 we can use as well. If I plug in 1, that's 3. 3 to the first power is 3, right? Times 1/2, which is 1.5 or 3/2. I like to use decimals now because it's a little easier to graph them. So let's graph. 0, 1/2, boom. I get 1 3/2, so that's 1.5. So 1, 1.5 is up there. And then let's plug in -1. If I plug in -1 there, that flips it. So now it's 1/3 times 1/2, which makes it 1/6, which is 0.16 if you think about it, or 0.167 or whatever. So again, that's very close. Now, you're not going to get exact answers. It's not a big deal, just as long as they're in a general neighborhood. And you can see that that graph takes off now. It goes and takes off. Okay, so that's what you get. So these are your 3 ordered pairs, again, if you ever have to take this online. Number 3 here. Again, I have 0, -1, and 1 for our x's and y's. If I plug in 0, what do I get? I just get -1. Remember I said it was just 0, comma a. That was another point. 1. 2 to the first power is just 2, -1, so that's also a -1. I'm kidding. It's a -2. What was I thinking? And then -1, if I plug that -1 in there, that flips it, so it's 1/2 times the -1, which makes it a -0.5. So that means my graph is going to go down. Okay, it's going to be on the opposite side, and it's going to kind of look like it's going down, but it's really a growth function. So -1, -0.5, which is right there, give or take. 0, -1, and then 1, -2. So again, I'm going to start really, 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 really low, and then I know I didn't hit the dots. It's not a big deal. Just try to get close. I'm trying to freehand draw this using like a little tablet, and it's not very good. So that's what happens. There is your function there for number 3. Okay, let's move on to some decay functions. Okay, here's the decay function right here. How do I know it's a decay? Remember, this is smaller than 1 and greater than 0. Right, it's in between 0 and 1. So again, my numbers I want to use are what? Oh my gosh, -1, 0, and 1. How convenient. Let's plug in 0. Remember, it's 0a, so it's 3. That's always going to be that. The -1, what happens to a -1? This flips, so now it's really 4/3 times the 3. Those cancel, so that's a 4. Then what happens then? I got to plug in a 1. So if I plug in a 1 there, that's 3/4. Well, 3/4 times 3 is equal to 9/4, which is really 2.25. So 2.25. So these again would be my ordered pairs if you were to do this online. Let's graph them right here though. -1, 4, 1, 2, 3, 4, up there, 0, 3, and then 1, 2.25, somewhere like that. So you can tell that this is now coming down. That's a really good graph. That's a really good graph. I'm going to try to graph this over again here. That looks a little bit better. It shouldn't be straight up there, but it looks a little bit better. So there you go. That's your number 1 there. Okay, what I want you guys to do is this. I want you guys to graph number 2. I know we have some fractions there, but that's okay. This was not on your paper. I just kind of made that up there, so just do that one. And then number 3 below it, this is a little harder. I want you guys to just try it. I'll kind of show you what's going to happen with it, but I just want you to try it, okay? So hit pause and then hit play. Try them and then hit play. Okay, number 2 here. Again, I have my 3 numbers, -1, 0, and 1. Find out what they are. If I plug in 0, what do I get? Oh, I get -1/2. Oh, man, that's hard. If I plug in 1, what do I get? I get -1/3. And then if I plugged in a -1, I get -3/4. So there we go. And now let's graph them here. So -1, -3/4, we'll say is down there. 0, 1/2, negative is right there. And then 1, -1/3 is right there. So this is a really slow one. And there we go, okay? That's as best as I can get it right there. Number 3, let's scroll down a little bit for that one. Again, I have my 3 values, 0, -1, and then +1. Find out what they are. I plugged in a 0. Now in this case, this is going to be a little weird because this is kind of crazy. Okay, this is x minus 1, and then I have this +3 at the end. So really, I have to actually figure it out now, okay? So if I plug in 0, this is really a -1, which then flips this fraction, which makes it a -8, +3 is -5. So this is where it's a little weird. You will not have anything like this on a power assignment. I just want to show you that there are more examples than what we're actually going to be doing. For sake of time, we don't have the time for this. Maybe in the future we can do this, but not right now. You will do this in pre-calculus, so that is okay. -1, let's plug that in. If I plug -1, that's really a -2, which flips it. So it becomes 4 to the 2 power, which makes 16, times a -2, which is -32, plus 3, which is what? Which is a -29. And then if I plug in 1, I get 1. That's pretty nice. So there you go. I can't even graph this one. Those would be my 3 values. Again, you will not have anything like this. I'm not even going to graph it. I'm just going to show you that other problems do exist.
Ow!
So you think Santa will like these red and green M&Ms?
I don't know. I never met the guy. He does exist!
They do exist.
This is the last kind of part here before you guys are getting onto your practice, because this is hopefully a pretty short video. Hopefully it's shorter than some of the Unit 6 videos. So growth and decay, percent increase and percent decrease. So again, if I have y equals a times, and then really this is a b to the t. T is our time. Okay, t is our time. A is, again, our initial value, what you start with. You're going to need to know that. And then R is the percent increase or the percent to decrease, but it's as a decimal. If you do not put it as a decimal, it will be marked wrong because you're not actually taking into account the actual decimal value. You're just plugging in a number. So percent of increase is 1 plus R, and then percent of decrease is 1 minus R. And again, R is a decimal, and then so on and so forth. So, for instance, number 4, give the percent increase or percent decrease for the equation. Well, we know this is an increase, so we have to label as an increase. Increase, I can't spell it. You notice my handwriting is terrible. This is an increase. How much did it go up? Okay, well, it went up 2 because it should be a 1, but it went up to a 3, which is 2. So really it's 3 minus 1, which is 2. But that's a number. I want to put it as a decimal. So 1, 2. So it's a 200% increase. Remember, changing a number to a percentage, we have to move the decimal 2 places to the right or multiply by 100. All right, you can't forget that. Number 5, this one here, I'm going to take 1, and I know it's a decrease because it's less than 1. All right, so it's a decay function. I'm going to take 1 minus 0.925. whatever that is, 0.075, right? 0.075. So if I need, it's 0.075, which is 7.5% decrease. Okay, 7.5% decrease. Okay, I want you guys to do 6 and 7 real quick. Pause the video and then hit play. Find percent of decrease, increase, and percentage. There you go. Pause and hit play. For number 6, remember this is going to be a decrease because it's less than 1 again. So then it's 1 minus 0.5, or it's 1/2, right? It's 0.5, which is a 50% decrease. 50% decrease. Number 7, this is an increase because it's greater than 1. So it's 5.26 minus 1, which gives me 4.26, but again, twice to the right. So 426% increase. Okay, that's that. Let's do the 2 word problems and let's be done. For each scenario, what's the scenario? For each scenario, write an exponential model. Basically, I want to write it in y equals ab to the x, and then we're going to use x and y. You can use technically different ones, but use x and y. I'm telling you right now, use x and y. So a baseball card is worth $50, and its value increases at a rate of 23.5% per year. So a baseball card is worth of $50. That's our initial. So y equals 50. I got to find the number that goes in here, our rate. Well, I know our rate is 23.5, which is really 0.23. So it's 0.235. But then I got to add 1 to it, right? Because it's an increase, that means I got to add it. Remember, up here it says 1 plus r. So 1.235, and then to the x power. So there is our equation. Using that, I want you to try the second one there. This one here, what does it start at? It starts at 300. This is decrease. That means it's 1 minus 0.037. Remember, I got to put it as a decimal. So that's 0.963. Hopefully I did my math right. And then I got to raise that to a power of x. So there's your equation for that one. Hopefully you got that one right. All right, that concludes your video here for 7-1. Hopefully it's not that long. I'm sorry if it is. But it shouldn't be that bad. Just graph them and do your stuff. There's probably a lot more problems there that you need to actually do, because it's really not a hard section. But again, take notes, do work, and you will be successful.